So this is question number 8 of the nuclear physics homework booklet. And to start off with, we are asked to suggest 2 reasons why an alpha particle causes more ionization than a beta particle if they've got the same initial kinetic energy. So there are 2 reasons why alpha particles cause more ionization than beta. Simply, alpha particles have a greater mass than beta, so when they collide with electrons in an atom, they're much more likely to ionize the atom. And an alpha particle travels much slower than beta, and so an alpha particle is much more likely to interact with an electron inside the atom, as it passes, than a beta particle is. So you get 1 mark for the first part and 1 mark for the second part of the answer. In part B, we're then asked to do some calculations. So we're told that a radioactive source has an activity of 3.2 times 10 to the 9 becquerel. It emits alpha particles, and they've all got the same kinetic energy of 5.2 MeV. This source is enclosed in a small aluminium container, and the aluminium container has a mass of 2 times 10 to the minus 4 kilograms, and it completely absorbs the radiation that the radioactive source gives out. First of all, we're asked to calculate in joules the energy that's absorbed from the source each second by the aluminium container. Well, the amount of energy that the aluminium container absorbs is equal to the amount of energy that the source gives out. So the energy is simply equal to the activity, which is the number of decays per second. So each one of these gives out an alpha particle of 5.2 MeV. So if I simply multiply the activity by the energy of each particle, it gives me the total energy that's given out per second in MeV. I don't want MeV though, I want joules, so I need to convert my mega electron volts into joules, and I do that by multiplying by 1.6 times 10 to the minus 13, which gives me 2.66 times 10 to the minus 3. So to 2 significant figures, because that's what all of the numbers in the question are to, that gives me an energy of 2.7 times 10 to the minus 3 joules. So that's how much energy the container absorbs. In part 2, I'm then asked to estimate the temperature rise of the aluminium container in 1 minute. And helpfully, the exam board have put 1 minute in bold to kind of show us that we're now not talking about a second anymore, and we're going to assume that no energy is lost from the aluminium. It also tells us the specific heat capacity of aluminium is 900 joules per kilogram per Kelvin. So automatically we should be thinking, right, okay, it's not a nuclear type question, it's a specific heat type question. So specific heat capacity, energy equals mass times specific heat capacity times by the change in temperature, which is what we're asked to work out. So the change in temperature is the energy divided by the mass and the specific heat capacity. Now we've worked out what the energy absorbed per second is, which was the 2.7 times 10 to the minus 3 joules. So in 1 minute it will absorb 60 times that, because if that's the energy per second, the energy per minute is 60 lots of that. So that's where this 60 comes from. The mass was 0.2, it told us that in this question, 0.2 times 10 to the 3, it told us that at the start, and the specific heat capacity is the 900 joules per kilogram per Kelvin. Put all of that in your calculator, gives you 0.9 Kelvin. So this container will basically, in 1 minute, increase by 0.9, the temperature will increase by 0.9 Kelvin. So in terms of the 5 marks, this was a 3-mark question, so basically you got 1 mark for correctly working out the numbers in MeV, 1 mark for correctly working out, for using this thing in order to actually calculate the energy in joules, and 1 mark for the right answer. And for this part, you simply got 1 mark for putting the numbers in the equation correctly, and 1 mark for the right answer. So that was question number 8 of the nuclear physics homework booklet.